Yeah?
Yeah.
Okay, so let's say we have a container. Like a water container, yeah?
The vertical lines.
Vertical container, we have a few vertical bars, vertical lines, yeah? So vertical lines. Like that. So our task is to pick two, and with these two chosen vertical bars, and we want to find out, we want to maximize the water that the container can hold, okay? So for example, if I pick this one and this one, right? So look, let's just look at these two lines, yeah? So if I pour, pour, P-O-U-R, how do you pronounce this word? Pour, yeah?
It means you don't have much money.
No, not pour. P-O-U-R, it means that...
You pour it in.
Yeah, pour the water in, yeah?
Oh, okay.
Yeah, pour the water in, and then it will be determined by the lower bar, right? Because the more you put the water in, and then you will overflow,
moving
right?
it towards the other,
Yeah.
other one will make it worse,
Yeah.
not make it better.
Yeah, do you get it? Yeah, it makes sense, yeah? And you are not allowed to slang the container, yeah? Slang the container. So you put the water in, and the volume is determined by the lower bar. Does it make sense, yeah? Okay, so another thing is these vertical bars are separated equally, so we can think of it as distance 1. Okay, so we are given this h array, which is represent the height of each bar, and we want to maximize the water by choosing any two vertical bars. Okay. Yeah, so how do we solve this problem? One easy way would be to do what? Look, there are n bars and we want to find out 2 bars. So what accurate can we use? Come on, guys.
We can use brute forcing.
Brute forcing, yes, that's a very obvious hint, right? I'm saying there are n bars, and then we want to find out which 2, right? So basically, I'm saying is that there are n things. I want to pick 2. So how many ways is CN2 means picking 2 out of n. Okay, so 3 apples, picking 2 apples out of 3. How many ways? 2. Okay. 3 apples, picking 1 apple. How many ways?
3.
Yeah, exactly. So basically it's the same, right? Picking x out of n is equal.
Picking apples out of apples.
Picking x items out of n is the same as picking n minus x out of n, right? Because what does it mean? Because look, there are n items, yeah? If I pick x items, and this is the same thing as picking n minus x items, right? When we pick 1 apple, we also get the way of picking 2 apples, and vice versa, okay? Okay, come on, CN2 equals n times n minus 1 divided by 2, yeah? We learned about that in a combination, right? So, obviously, this is n squared, eh? Am I right? Yeah?
Yeah.
Okay, so now we can brute force. Let's brute force. Yeah, brute force is very useful, yeah? But, what's the time complexity? What's the time?
Square.
Yeah, I'm just writing here. Look, and O(n) squared, yeah? N times n here, yeah? O(n) squared. So let's brute force. Answer at the beginning we hold no water, which is 0, and equals length height. H is the height for each vertical bars. And then for the left, right? The index of the left bar in range n. Okay, for right bar in range. Okay, so can you give me the parameters for the right bar? The right bar, come on, anybody. Right bar start with what? The L bar is from 0 to n, and right bar is what? From the... What should I put the first parameter? Look, if I had determined the L, plus 1. Because, if it's not equal to L, right? So we plus 1 here. Right? And then look, then answer equals maximize. We want to maximize the answer of what? Come on. Can you tell me this? And then we return the answer. This is very easy, yeah? Okay? Anybody? So if I have an air and R, okay? So if this is air, okay? This is air. This is R, okay? So what's the volume? What's the volume of if this is air, this is R? The height here is h air. The height of this one is hr. So what's the volume of this? What's the volume? You know the volume is the rectangle, yeah? What's this bit? How much is this bit? Yeah, but you don't know which one is bigger. Yeah, so we
But
pick.
that one is bigger.
Yeah, I know. I'm just giving you an example. But computer, this is the value h air hr. So you are basically saying this is mean of h air hr, right? Yeah. Okay. So this bar times what? What's this bar? Come on. This is we know this, and then what's this?
1.
Now L and R is not necessarily separated by 1. So what's the distance between L and R?
R minus L.
Well done. Exactly. Okay. Yeah. Okay. Yeah. So look, this is the. Come on. Ryan, what you doing? So what I'm saying here is that this is the volume of the rectangle, yeah, for this water, if we chosen air and R, okay?
So you have a min, or because the smaller
Yeah.
one is determined by the height.
Yeah.
So this is the minimum
Of these two, yeah.
Yeah.
Which is huh?
And times the length of this, which is R minus R.
Well done. Ryan, you get it? Okay, brute force, O(n) square, okay? O(n) square. It's a bit slow, okay? But we can do it better. We can use the 2-pointer thing. But how can we do this 2-pointer thing? Look. Okay, so let's look at this example, yeah? If we are air at the beginning, we set it to 0, R set it to n minus 1, which is the leftmost and the rightmost. If we say air, the height, if we say air is smaller than R, right? So how do we move the pointer? We are supposed to move one, right? So is it better we move the lower bar or move the higher bar? So now we know the air bar is smaller than the R, right? So we want to move the answer is we want to move the shorter bar towards the center, right? Let's say if we move the bigger one towards the smaller one, what will happen? Let's say
It might be so tiny that it might be that it might be only like this.
yeah. No. Look here. This is R here, right? This is longer than air. And if we move here towards the left, what will happen?
The length here will come like shorter.
The length will be shorter. Okay, so that's right. So let's say, let's see if we. Okay, so if this is air, right? So let's say currently the volume is mean air R times T. Okay, so look, this is T. Okay, let's say the distance here is T, right? If we move the R towards the left, the longer one. So let's say if we move it somewhere here, and then the distance is T1, which is shorter, right? T1 here, T1, and the height is what? Is mean air and R1, okay? We are not sure how tall is R1, right? It could be very tall, it could be very small. Okay, so let's look at this. T1 is smaller than T, right? Smaller than T, right? Yeah, because it moves towards each other is smaller than the original places. But look at this one. Mean air R. Okay, so mean air R and mean air R1. Okay, so look, if this is very tall, R1 is very tall, and the mean air R1 would be air, right? If it's very short, mean air R1 is R1, which is smaller than air. So so what does it mean? It means that mean air R1 is always smaller or equal than mean air R. Am I right? Because it's always determined by the smaller vertical bar, right? So originally the smaller bar is air and R, right? Because it's smaller. And if we keep moving to the left, right? So if this R is very tall, then the mean of air and R1 is air. If this is very short, the mean of air and R1 is R1. R1 is smaller than air, yeah? So in both cases, the first case is equal to air. The second case is smaller than air, right? So the volume, yeah? If we keep moving left, we don't get a better volume. Am I right?
Yeah.
Okay, so what does it mean? Look, if I move a taller bar towards the left, anyway, we don't get a better choice. So what does it mean? In other words, it means that we don't need to try these R, right? Because we know we don't get better R. So we don't move it. So in that case, we just move the L towards the right. Right? Because look, if
But this thing will get squishier.
in both, yeah.
Get something like that.
At the beginning, it's on the left, on the right. See, they will be squeezed anyway, right? They'll be squeezed. They're moving towards each other. What did I say? If I move the R towards the longer one towards the shorter one, we don't find any choice. We just pull that. Well, on any better one, so we just pull that, right? So if we find out, if we know already, there's no point, there's no better gain if we move the longer towards the center, then we just don't move it, right? Yeah? What's brute forcing? So with each L, we try each R, right? But now I'm telling you this, is with this L, we don't find any better choice than this R, the longer one. Right? Because the distance is shorter. Right? So we are actually brute forcing already, but we don't try it. It'll be like brute force with some optimization, right? By moving the left to the right, what will happen? We could get something like that, right? Look. What did they say? Look.
Yeah?
What did they say? Come on. If I move the left to the right, I could find something here. And then which is longer? And what does that? How does that matter? The volume will be potentially bigger. Do you get it? Yeah? This is not a strictly proof of the solution, the two-pointer thing, okay? But if we want to actually prove it, we need to use the mathematical contradiction to do it. But this is a little bit out of scope of this today's talk, okay? So I'm not going to talk about it. But let's talk about this the two-pointer thing, okay? So L equals 0, R equals n minus 1, n equals the length of the h, right? The answer at the beginning will be 0. Like why? Look, this two-pointer thing, yeah? We talk about the two-pointer thing. Do you still remember? We have a sorted number. 1, 3, 5, 6, 9, 11. This is the sorted numbers, yeah? Can we find the two numbers added up to 10? Come on.
9 and 1.
9 and 1. How do you find the 9 and 1?
I use my number ones.
Eric, how do you find 9 and 1 added to 10?
Because
I'm
these
L here.
number ones,
I'm R here.
you use 2 pointers.
Yeah, 1 plus 11, 12. Come on. 1 plus 11, 12, which is bigger than 10. So which side should I move?
Smaller.
Look, Eric.
Right.
Right, yeah, because it's bigger now, and I have to move it to the left, yeah? Okay, so, yeah, exactly, okay? Do you get it? Okay, this is probably not a good example. Let's say, do you find any two numbers that add up to 8? Okay, so can you simulate this again? Add it up to 8. So look, 1, 11, 12. What should I move? Left hand or right hand should I move?
Right.
Okay, I'm here. 10.
Right. White.
Then?
Left.
Yeah, because 7 is smaller than 8, right?
Left.
So,
Right.
9.
Right.
Yeah, and then you got it. Yeah, do you get it? This is the two-pointer thing, right? Yeah. So now here, y left is smaller than r, right? Answer, this is the same. We are trying to maximize the answer, and then there will be mean of HL, the volume that determined by the lower bar, okay, times R minus L, right? And then look, if HL is smaller or equal to HR, what should we do? Else, what should we do? Come on, we're talking about. If the lower bar, look, Eric. If the L, the height is smaller than the right, where we should move? HL is smaller than R. So which one we should move?
Left.
Left, yeah? Because I was just talking about that for 10 minutes. Why moving the right does not give us a better choice. Do you get it?
Yeah.
So,
Exactly.
so that would be L.
Okay,
plus equals 1. And then else R minus equal 1. Okay? And then return answer. Okay? What's the time complexity? Come on.
O-N?
O-N, yeah? O-N?
Yes.
O-N.
That's what I was about to say.
Well done. Okay. Yeah, O-N. Yeah, because look, why is it O-N? We can prove. We have 2 pointers. At one step, one pointer moves towards the other one. You know, you pick this one or this one. So when they meet, how many iterations, how many steps,
N.
both. Yeah, and exactly, yeah? Yeah? It's like Eric and Ryan, you stand 10 meters apart. Right? And one step, yeah, either Eric or Ryan walk towards 1 meter towards each other. Yeah?
A bit boring.
Yeah. And then when you meet in the middle, somewhere in the middle, the total step would be 10. Right? Yeah? Do you get it? Okay, so that's the time complexity O1, okay? Space complexity is O1 constant space, okay? And yeah, that will be it for today. Good job.
Bye.